All right, next question, number 28. What is the hybridization of the central atom in a molecule, or in the molecule, CH3Cl? What best classifies this molecule? Change that to this. Okay, so this is CH3Cl. It's got 3 carbons and 1 chlorine around it. So that's a total of 3 things. So we go SPPP. So it's sp3 hybridized. And ultimately, is this a polar or a non-polar molecule? Well, it's not symmetrical. So it's going to be an sp3 hybridized polar molecule. All right, so question number 29 reads, which of the following molecules only has sigma bonds? So what is something of these options that only has a single bond? And we are left with N2, H2, CO2, and NH4. And what I realize now is that I'm going to have to change this. Let's go with pause. Okay, so when we look at these different options, we've got nitrogen, and a way that you can approach this problem is to come up with the Lewis structure for this molecule. Nitrogen is they are each bringing in 5 electrons, so N. So that's a grand total of 10 electrons that they need to come up with. Boom, 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 boom. That's triple bond. That triple bond consists of 1 sigma and 2 pi bonds. Okay, next up is hydrogen. Each hydrogen is bringing in 1 electron. So HH. That's 2 electrons shared between them. Done. Carbon dioxide. I'm drawing carbon dioxide quickly because of the fact that we see carbon dioxide pretty regularly and talk about it pretty regularly. So each one of those has a single bond and a double bond. So that's a sigma and a pi bond on each side of that central carbon. So C is out, A is out, and we are left with none other than answer option D. And answer option D, or sorry, A and C are out. Now we've got C, D, which is urea, which is H2CO. So if you were to do the math to add all this up, you would learn that you have 2 electrons from your hydrogens, 4 from your carbon, and then 6 from oxygen. So that would be a total of 12 electrons. Okay, our atom that is farthest to the left that's not hydrogen is going to be our central one, and that is carbon. So if we drew a structure like this, HCO oxygen, okay, that would be 6 electrons. If we complete the octet for oxygen, that's going to be 6, that's 12 electrons drawn. When we see those 12 electrons are drawn, we realize that carbon has not had a complete octet. So then what we want to do is erase 2 of these electrons off of our oxygen. And now we've got something that looks like that. Well, that is a structure where carbon has a complete octet, oxygen has a complete octet, and hydrogen has a complete octet. However, this question is not about that so much as which molecule only has sigma bonds. Well, this is a sigma and a pi bond, so urea is out as an answer option. So your correct answer for this one is none other than B, H2. So that was question number, falling behind a little bit. So I got to read number 26. 7 is B for 27. 28 is D. 29 is B. And 30. What type of bond is formed when 2 atoms share electrons equally? Ionic bond? Nope. Hydrogen bond? Nope. Covalent bond is our correct answer. B. So that's number 30. Question number 31. Which of the following molecules has a trigonal planar molecular geometry? So trigonal planar is AX3. So it has 3 things surrounding it. Now, if you look at ammonia, and you're going to put that together, you're going to come up with something that looks like this. Nitrogen's got a complete octet. Each hydrogen has a complete octet. Water, well, you got lone pair, lone pair, lone pair, H, H. So that's a central atom with 4 things around it, kind of like ammonia. Urea, we just drew a little bit ago, and that is going to be our C double bonded oxygen. There we go. This is going to satisfy, despite the fact that that's a double bond, this completely satisfies the criteria for a trigonal planar geometry. So 31 is C. Okay. Now I got to pause because I got to change my questions up. All right. How many sigma and pi bonds are there in a molecule of ammonium? Well, NH4 plus 4 sigma, 0 pi. What is a hybridization of a molecule with a Vesper notation of AX3E2? That has 5 things around it. S, P, 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 D. So sp3d is the hybridization of that. All right. So that was question number 33. The answer is C. 32, the answer is A. Which of the following molecules is polar? I'm going to change this question. Which of the following molecules is non-polar? Okay, we got H2O, CHCl3, NH3. Well, NH3 has a lone pair of electrons. CHCl3 is asymmetrical. H2O has 2 lone pairs of electrons. SF6 is our only molecule that is symmetrical, and that is therefore non-polar. Number 35. In the Lewis dot structure, so 34 was C. In the Lewis dot structure of ammonium, how many lone pairs of electrons are there on the central nitrogen atom? 0. Which of the following elements has the lowest electronegativity? We've got carbon, nitrogen, oxygen, fluorine, sodium. Our trend for electronegativity is up and to the right. Our most electronegative element is fluorine. Sodium is therefore your least electronegative, but I'm going to remove that. So what we're looking for is farthest to the left on the periodic table. So we are looking at carbon. 36 is A. Okay. Then number 37, what is the total number of valence electrons in the Lewis dot structure for the iodate ion? An iodate ion is IO3 minus. Well, that's bringing in 7. There's 3 oxygens. Each one's bringing in 6, so that's 18. So we're talking about 25. But then we got a negative charge there, so that's 26. So D is our correct answer. For 37, D is the correct answer. Pause. All right. Question number 38 reads, which of the following is not an example of a hydrogen bond? Okay, so the first part of this, we've got OH, and answer is A through D. OH, so there's our covalent covalent bond between oxygen and a hydrogen. So that oxygen is our electronegative element. Now we need another electronegative element. And what our best bets are nitrogen, oxygen, and fluorine. I'm going to push that down to bromine instead, but this is not an example of a hydrogen bond where there's that bromine that kind of latches onto that hydrogen. Okay, number 39. So 38 is B. 39. How many different positions can an f orbital have? Well, an f orbital can have a total of 7. An s orbital can have only 1 different orientation. A p orbital can have 3. A d orbital can have 5. And an f orbital can have 7 different positions, 7 different orientations, 7 different m sub l values. Next up is which of the following atoms has, or which of the following, I'm going to say atoms / ions, has a full d orbital. Okay, so we've got Zn2 plus, and I'm going to go ahead and share my screen to the periodic table. We've got zinc 2 plus. Okay, well, zinc, oh yeah, it's at the tail end of the d orbital. But if it's zinc, a zinc cation, whether it's +2 or +1, +2 means that it's lost 2 electrons. So it actually has the same electron configuration as nickel. Zn plus has the same electron configuration as copper. So if that was just Zn, then the answer would be Zn. But zinc cations are not a good option. Next up is copper. Well, a copper cation, Cu +1, that's going to have the same electron configuration as nickel. Gallium 2 plus has the same electron configuration as copper. And germanium, Ge 2 plus, that has the electron configuration of zinc, so that has a full d orbital. So our correct answer there is Ge 2 plus. What is the bond angle in a molecule with a trigonal planar molecular geometry? Trigonal planar, that's 3 things. That is 120 degrees. C is the correct answer. 42. What percentage D is an sp3d hybrid orbital? We've got S, P, 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 D. So it's 5 parts. One of those is D. Therefore, our correct answer is B, 20%. Calculate the energy of a photon with a wavelength of 200 millimeters. Okay, for this one, what we've got to do is we've got to convert our wavelength 200 millimeters to meters. So 200 mm, there are 1,000 mm in 1 meter. So I'm going to go with 200 divided by 1,000 equals 0.2 meters. Okay, now we've got an equation, E equals H times mu, is Planck's constant. Planck's constant times frequency. Then we've got another equation that is C is equal to lambda times frequency. So when we take C over lambda, this is our lambda, 0.2. That's equal to our frequency. We can plug that in there. So C is 3 times 10 to the 8th, 0 divided by 0.2. That is our frequency. So 3 7 8 divided by 0.2. E equals 6.626 times 10 to the -34th times 1.5 times 10 to the 9th. That's going to get us A, or 9.94 times 10 to the -16th. So A is the correct answer for that one. All right. Well, I hope that was helpful. I hope you have a good one.